Hello guys, let's see how the cast rule actually works. So, let's start off with what is the cast rule. Well, cast rule is cos all sine tangent, meaning in the coordinate system, let's start with C. This C stands for cos and secant. Cos and secant. They are positive in the fourth quadrant, and in the first quadrant, all of the trigonometric functions sine, cos, tan, sec, cosec, cot all are positive. And in the second quadrant, the sine and cosine are positive, and in the third quadrant, tangent and cotangent are positive. But have you ever wondered why? Why are cos and sec positive in the fourth quadrant, sine, cosec in the second quadrant, and why is everything positive on the first quadrant, and tan and cotangent are positive on the third quadrant? So let's start with a line from the origin and making an angle theta with the x-axis going this way, and let's say the unit length is just 1. So what I want to find is the coordinate at this point over here when this line has traveled 1 unit, making angle theta with the x-axis. Well, thanks to vector resolution, I can find the length from here and from here due to this vector over here. So you can also use trigonometry to find that, which is just the vector resolution, and I want to find the point over here. I want to find the x value for this coordinate over here. So this part will just be cosine of theta, because base by hypotenuse, base will be just cos theta now. And similarly, the y value will be sine theta. Perpendicular by hypotenuse is sine theta, perpendicular will be sine theta. So that means the coordinate over here is cos theta and sine theta. In the first quadrant, both sine theta and cosine theta are positive, meaning that tan theta, which is just sine theta by cos theta, will also be positive. And in that way, cosec, sec and cot, all of them will also be positive. So this checks out for A. Now let's go to the second quadrant, and what I'm going to do is draw a similar line like this, which is also 1. Don't really mind this, okay? And again, from here to here, the y value will be positive, because in the first and second quadrant, y is positive. So this is sine theta. But here, cos theta will be negative. So this will be negative cos theta, meaning the point right here will be minus cos theta, comma sine theta. So that is why we'll have sine theta and cosec theta positive over here, and since the cos theta is negative, that means sec theta will also be negative, meaning that tan theta will also be negative as well as cot theta. So that checks out for S. Now let's go to the third quadrant and similarly draw a line like this, which is 1, and here both the x and the y will be negative, meaning that here this will be minus cos theta minus sine theta. And now here tan theta will be equals to minus sine theta by minus cos theta. The minus minus will cancel, giving us tan theta is positive, and cot theta 1 by tan theta is also positive, and the rest will be negative because you can just see that. And for the fourth quadrant, I think you guys are getting the gist of this. This will be cos theta minus sine theta, because here x will be positive, y will be negative, and here cos theta and sec theta will be positive, and the rest will be negative. So this will check out T and C, meaning we just worked out how the cast rule actually works. And here, instead of 1, you can also write some other lengths such as A, R, 5, etc. But you just have to know that the trigonometric ratios in itself will follow the cast rule. So there we go. And if you learned something new, please like and subscribe. Thank you.